Hi everybody! So in today's notes we're going to start talking and going really into depth about the different ways that we can write an equation and the different types of equations we can use, as well as how we can graph an equation and how we can check to see if two equations are equivalent. So the first thing is, when we are writing an equation of a line, we always need two pieces of information. We're always going to need a starting point, and we are always going to need a pattern. If the starting point has an x value of 0, so when the x is 0, then we use the symbol b, which stands for begin. So an example would be that if I were to tell you the b is 7, you would be able to make a little mini table where the x is 0 and the y is 7. Another word for pattern in mathematics is also the slope. And we use the symbol m for slope, which stands for move, because the slope tells us how to move between points on a graph. Now, when we write these types of equations, we give them two different names. When the starting point has an x value of 0, we call it the y-intercept. We do this because if we were to graph the point, it's going to end up on the y-axis. When that happens, we call this equation slope-intercept form, because the two pieces of information we have are the slope and the y-intercept. When the starting point does not have an x value of 0, so when it's any other point, we call this point-slope form, which stands for any other point and the slope being our given information. So what we're going to do in these problems below is we are going to write the equations, and then we're going to we're going to describe what type of form of the equation we used. In problem number 1, what I'm doing is I'm telling you the slope, which is the pattern, and I'm telling you the starting point. What I like to do is make a little mini table and put my starting point in the table. So the x would be 3 and the y would be 4. From here, using what I already know about writing equations, I would start my equation with y of x, because the output goes on the outside and the input goes on the inside, equals, now I'm going to take my starting y value, which is 4, then I'm going to say plus 5, because that's my pattern, and if I were looking at the table, it tells me the pattern would be plus 5. And then I'm going to have parentheses x minus 3. And the reason I'm putting minus 3 is that I always want to get back to 0. So if my first x value is a 3, I would need to go backwards 3 places to get to 0. This equation right here should remind you it's exactly the same thing we've been doing since Module 1. For problem number 2, we have slightly different given information. M means slope. So in this case, this is my pattern, is -2. B means begin. So it tells me that in my table, I already am beginning at 0, and the y value is 7. To write my equation, I would say y of x equals my starting value, which is 7, minus 2, because that's my pattern, parentheses x, and then I don't need to adjust at all. I'm already starting with 0, so that would be my final answer. Next, in the next problem, we have an m and we have a starting point. So the m is our pattern, which is our slope. And this point right here is our starting point. I'm going to make a little mini table, and my starting point will be 2 comma negative 3. So my equation will start y of x equals my starting y minus 1/4, because that's my pattern, parentheses x, and then minus 2 because I need to get back to 0. For problem number 3, instead of giving you the pattern, I've given you 2 points. So what I would do is I would make a table with 2 points in it, -1, -3, and 2, 3. From here, I can use the same technique for finding slope that I did before to find the slope between these points. To go from -3 to 3, I would add 6, and to go from -1 to 2, I would add 3. So my slope would be rise, which is 6, over run, which is 3, and 6 divided by 3 simplifies to 2. Now I'm going to write my equation. So I'm going to have y of x equals my starting point, which is -3, plus 2, because that's my pattern, parentheses x, and then I'm going to put plus 1, because to get back to 0, I would go to the right 1 space. Now let's classify these equations as either slope-intercept or point-slope. So the first equation, the starting value, does not start with 0. Therefore, we would call this point-slope form. In the next equation, the starting value does start with 0. So we would call this slope-intercept form. In the next equation, the starting point does not start with 0. So we would call this point-slope form. And in the next equation, the starting point does not start with 0. So again, we would call this point-slope form. Now another thing we're going to need to be able to do is to take an equation that's already been written and figure out how to make the graph using the information from the equation. So in this equation, I can see that this is point-slope form because the x had to be adjusted to get back to 0. The way that we normally write point-slope form, we usually put the 1 at the beginning. So I'm going to rewrite this in the way that makes more sense to me, which is to put the 1 at the beginning. And then I'm going to put minus 2/3, parentheses, x minus 2 at the end. So just flip the 1 to the beginning. From here, I can tell that the starting point that was originally in my table would have been 2 for the x, because I had to subtract 2 to get back to 0, and 1 for the y. I can also tell that the slope for my graph would be -2/3. Using that information, I can make my graph. So I'm going to start at 2, 1, and from there, I'm going to go down 2, right 3. I'm using rise over run. Down 2, right 3. Or I could go up 2, left 3, up 2, left 3. Once I do that, I would just draw a nice straight line through my points. Now let's say that I give you a graph and I say write the equation. So kind of going the other way. If I give you an equation, you need to be able to make the graph. If I give you a graph, you need to be able to make the equation. So in this graph, I would start by making a table. I'm going to try to find some nice points on the graph. So one nice point that I notice is this one. I've got another one here, and I've got another one here. The first nice point is -3, 4. The next nice point is 0, 2. And the last nice point is 3, 0. From here, I would do my change in y, so this would go -2, over my change in x, and this would be +3, which means my slope would be -2 over 3. Using now my table and my slope, I can write my equation. So I would have y of x equals my starting value, which is 4, minus 2/3 parentheses x plus 3, because I would need to get back to 0 by adding 3. Finally, sometimes we're going to be asked to determine, so that means decide, whether the equations are equivalent, showing our work to justify our answer. When you want to determine whether these two equations represent the same information or not, what we're going to need to do is rearrange this equation, because that's the one that's a little bit more complicated, and see if the simplified equation matches this one. So, in order to rearrange this equation, step number 1 is going to be to do distributing. So I'm going to take the -3 and I'm going to distribute or multiply it by everything that's inside the parentheses. It's like we're passing it out to everything that's inside. -3 times x would be -3x. -3 times -3 would be +9. And all I'm going to do is drop down the -7 and not change anything. The second step is going to be to combine like terms. Now, combining like terms means taking the numbers that do not have an x and putting them together. 9 minus 7 would give me 2. Everything else is just going to drop down. So the y, the equals, and the -3x plus 2, because my answer was a +2. Since this equation matches this equation, the equations are equivalent. That's it for this video. The next thing we're going to be doing is some practice problems to practice these skills, so I will see you in class on Friday.